Okay, and on this example, we're going to be solving quadratic equations by using the quadratic formula. So over here I have the quadratic formula. For this particular quadratic equation, what we have to do is identify a, b, and c for the quadratic formula. In this case, a is 5, b is negative 11, and c is 2. So now we're going to plug those numbers in to the quadratic formula. X will be equal to negative b. Negative b looks like negative 11. So we have to put the negative there in addition to the negative that we bring down with our number 11. Plus or minus the square root, negative 11 squared, minus 4 times a times c, all over 2a. So that's how it's going to look after putting the numbers in for a, b, and c. Now we have to run through the calculations. Negative 11 turns into positive 11 plus or minus the square root of negative 11 squared would be 121 positive. Negative 4 times 5 times 2. Multiplying the three numbers together, you get negative 40 all over 10. Okay, and now we subtract 121 minus 40. That'll give us the square root of 81 all over 10. The square root of 81 is 9. So what we're going to do next is write this as 11 plus or minus 9 all over 10. Now what we're going to have are two answers based on the fact that we have this plus or minus in the middle. What we'll have here is equal to one of two things, 11 plus 9 over 10 or 11 minus 9 over 10. So we have to break it down into the two different cases. Up here, if you add, you're going to get a 20 divided by 10, and that's equal to 2. Down here, subtracting the numbers, you get 2 divided by 10. And you make sure to reduce that into the lowest terms of 1/5. Okay, now we're going to try solving another quadratic equation by using the quadratic formula. In this case, notice that there's some numbers on one side of the equation and some numbers on the other side. Before we start plugging into the quadratic formula, we need to make sure everything is on one side of the equation and the other side is 0. So what that is going to involve on this one is we need to add the 5 over to both sides, making this into 2x squared minus 8x plus 5 equal to 0. Once we do that, then we'll say what a, b, and c are equal to. In this case, a is 2, b is negative 8, and c is 5. And if you'd like to practice your skills at setting up the formula, go ahead and pause the video here, and I'll go ahead and work out the question in just a second. When we plug it into the formula, it's going to be negative b, so we have to put negative in front of b, which is negative 8. So we get again negative 8 plus or minus negative 8 squared minus 4 times a times c all over 2a. Okay, so it looks something like this. Now we have to work out the numbers. We're going to get a positive 8 plus or minus the square root. Negative 8 squared would be positive 64 minus, multiplying the numbers together, we would get 40 all over 4. Okay, now if we do the subtraction, we're going to have 8 plus or minus the square root. 64 minus 40 is 24 all over 4. And now this is a situation, if we try to look at the square root of 24 is not an easy number. Not like the last example where we got just a whole number as a result. So when we run into a square root like this, it's possible to simplify the radical or simplify the square root into its lowest terms when we can't take the square root directly. So how we do that is we look at the number 24. And we ask ourselves, do we know of a number that we know the square root of that divides in to 24? So think of numbers that you know the square root of, like 4 or 9 or 16. Can one of those numbers divide into 24? And indeed, 4 does divide into 24. 4 times 6 is 24. So what I'm going to do is look at 24 as 4 times 6. When I do that, I can go ahead and take the square root of the number that I know. The square root of 4 is 2. So that's just going to turn into a 2 by itself, not inside the square root anymore, leaving the number 6 as the only number inside the square root. So that's what we'll do when we want to simplify. Try to bring out numbers that we know the square root of that we can bring out, leaving us a smaller number on the inside of the square root. Okay, so that simplified it down to this. Now we can actually take it slightly farther. In the top, notice that there's 8 and 2. Both of those numbers have a common factor of 2. So what I'm going to do is factor out a 2 in the numerator. 2 factored from 8 leaves us with 4. Factoring the 2 from the square root just leaves me with square root 6. So I've brought out the 2 to the front, and that's still all over 4. Once you factor out a number, then you can reduce it with what's in the denominator. So 2 and 4 reduce to 1 and 2. And what we're left with on top is 4 plus or minus the square root of 6 all over 2. And that's actually now the most simplified answer we can get it to. The 4, the 2, and the 6 are all not going to reduce. The only way we can reduce is if we did what we did in the last step, which is to factor a number and then reduce it from the numerator and denominator. And so this would be the most simplified form of our answer. One last side note about solving quadratic equations. You may run into solutions where you get square roots of a negative number. In those cases, what you want to do is rewrite your radical by using I. I stands for the square root of -1, and it involves things called imaginary numbers. So when you run into the square root of a negative number, go ahead and put an I out in front and make the number on the inside positive. The I will be there to stand in for the negative part of your number. You can put it out in front, and that'll take care of the square root of the negative number, leaving you with just something like this instead. And in this case, there's no other simplifications that can happen when we have the square root of 43, because it doesn't break down any further, and there's no other numbers that'll simplify as well.